We can just start. The next one is Carsten Thiel, former co-worker of mine and a platform I've been working on as well. So I'm looking forward to see where it has come since I left. We had another talker that unfortunately couldn't come, Norbert from Norrøna themselves. But I guess I'll hand it over to Carsten.
Yes, thank you, and thank you for having me. So this is about Norrøna's story, migrating to the cloud, modernizing the infrastructure along the way. We called it from storms to cloud. I mean, this looks pretty much like Bergen today, although this is one of the official Norrøna advertising images. In case you don't know, Norrøna is a family-owned company, almost 100 years old, with 110 employees in Lysaker, just outside of Oslo, and they produce sustainable, high-quality outdoor clothing and gear. They take approximately more than 3 years from conception to market, and also with sustainability, high quality, and so on, they're very much the opposite of fast fashion. I myself worked for Thiel, specifically Thiel Create, the consulting branch, which has about 10,000 employees worldwide. We can help you with all sorts of things, including Kubernetes and Terraform, which we'll be talking about today. So, as Anders said, Norbert couldn't join us today, unfortunately. He is a software architect at Norrøna, and he's responsible for their IT and cloud strategy. Norbert started this project basically 5 years ago, along with a few former colleagues. Some of them are here today, some even in the room. As Anders said, and we'll hear one of those stories. Maybe you were here in the previous talk, the Friday afternoon, something's gone wrong. We'll come back to that in a few minutes. As I said, I work for Thiel with platform engineering, Kubernetes and Terraform, been doing this for 1.5 years, and also been on this project for the past 1.5 years. But before we talk about the most recent things, we should get back to the dark ages, where it all began, the good old times, also known as the on-prem data center world. Norrøna started out with monolithic architecture with quite a lot of IIS servers, way too many if you ask Norbert. One of the things that annoyed the most is that any single change to any kind of thing in production takes about 15 minutes of downtime for the entire website, which is not so great if you're trying to sell products to your customers. Infrastructure changes also took very long. They had to go through ticket systems. Not the most immediate user experience you'd want. And there's also some limitations on how much visibility you have into what's actually going on, logging or any kind of metrics and so on. So they made the decision to restart and basically go for a greenfield deployment to Google Cloud, starting from scratch. The plan: do not do a lift and shift. So just moving these machines over to virtual machines in Google won't do anything except be more expensive. So instead, the idea was to do a gradual migration, move one application at a time. While you're at it, rebuild them, make them cloud-native applications, small domain-specific services, not necessarily microservices in the very explicit or very strict definition, but very small services that deal with one single part of what your business does. And along the way, they went for modernizing everything, switching technologies, introducing containerization, replacing C# and Java with .NET Core, going from SQL Server to Postgres. And one of the core ideas was to start small, one database, one cluster. There was a copy for testing purposes, obviously, but that's basically it. You have one database server, you have one cluster, and you start from there, and then if needed, you grow over time, adopt, and so on. The platform, as I said, Google Cloud with Kubernetes. The idea was to have it very resilient, to be able to deal with downtimes, so multiple duplications, some sort of high availability concepts. A lot of automation, everything goes through workflows. Any change to the application via the Git commit, you build the image gets deployed automatically, all that. We set up Google with Terraform, Argo CD into the cluster, Prometheus and Grafana for the observability. And most recently, we've also added a security mesh to have some more security separations, also some network policies that we're introducing, and being able to encrypt traffic without the application having to deal with it. And all this is done, all the automation is done with GitHub Actions. Underlying, there's a few more services. PubSub is used for communication between the services unless there is a need for an immediate reply. So whenever possible, there's a messaging queue being used. There's Redis for the live backend, which holds all the live data that the applications use. But there are, of course, databases in the background. BigQuery and Looker are used mostly for the business parts that deal with the logistics and supply chains that need to generate some KPIs to find out what's going on. And this is ongoing work right now where they're improving these services. Norrøna has also been playing a bit with Vertex AI and machine learning using Google's Gemini system, the recommendation engine for providing users feedback on the website of this might be a product that might be of interest to you if you're looking at this one. So where are we today? As I said, there still is the on-prem data center on the one side where the actual website is still running. We also have warehouses, factories, we have stores, shipping, payment services that are completely outside the control. And in the middle, we have the Google Cloud. On the Google Cloud, we have a Kubernetes cluster that runs some of these applications. Some examples here, and as I said, for example, shipments. There's one shipments application that deals with all the shipments companies, be that Posten, be that PostNord, be it DHL, or whoever you want around the world. But it's still very specific to the shipments. The payments are dealt by something else. We run this with Argo CD. We're also using Argo CD to install both these applications and the platform parts like Istio, external secret manager that gets the secrets out of the Google Secret Manager. Prometheus with Thanos for the metrics long term. All that using application sets if you were in the previous talk. And if you're looking forward to the GitHub, the Argo CD versus Flux one, to make Istio work in Argo, we're using the sync-wave feature, which was one of the most interesting parts to get working because Argo's approach to eventual consistency doesn't really work nicely with Istio. Then we have underlying services, Redis, I mentioned it, Cloud AI, cloud storage, BigQuery, SQL, and the PubSub service, all this provisioned via Terraform. So this is where we are today. This is where we've come. We've made some changes. Some of them are a bit hidden here. And I want to tell, well, yeah, of course, these things are all talking to each other. Yeah. So let me talk about some of the harder lessons we've had. There's 3 stories here about things that did not go quite as planned and where changes needed to be done. The first one was actually trying out the Postgres just-in-time restore from backup. What was happening was that suddenly on a Friday afternoon, images started to slowly disappear from the websites. One product image at a time was disappearing, and it was at first not quite clear why this was happening, though there was a background shop that's in charge of making sure all these thumbnails are up to date, and that was slowly deleting all these files and also removing their references and their metadata and so on from the database. And it turns out the cause was a very short Google Drive outage, which caused Google Drive to respond with a 500 error, and the application thought, oh, I'm getting an empty reply, all the images are gone, then I'll go and delete them all. Yeah, well, so much for the resilient design I mentioned earlier. So this database needed to be restored because not just the images needed to be restored, but also the database references, which image should go where, what are the metadata so that you can find these images, what are the products that are actually listed in these images, and so on. There were already, of course, daily backups. That was all existing, including just-in-time backups. But if you want to restore this, you have to restore it to an existing instance. And I said earlier, we started with one database server. So you don't want to override that. So you have to create a new one, but then the Terraform code wasn't quite set up in a way that you can easily have two database servers, because the assumption was there's only one. So that was a bit of fun. Of course, in the end, this all worked out. It was a recovery to a new instance and then moving the database back. Restore the entire database to a server, to a new database server instance, and then copy that particular database you wanted back to the server that's actually in use in production. Yeah, so a few lessons learned in this one. Obviously, the application shouldn't delete everything just because Google is temporarily answering with 500. But also the workflows on what the application is doing, how quick it's doing this, all these kinds were improved. Also some better understanding of the backup and looking at this restore functionality. You can only restore either overwrite the existing one or overwrite another existing one. These are things you have to account for when this, or plan ahead for when this situation occurs. And of course now we're splitting also over multiple database servers, also for load balancing issues. The other very important lesson was to have predefined communications channels within the company, because you can imagine if product pictures are slowly disappearing, people start to notice. Everyone was trying to reach Norbert. His inbox was overflowing and different channels and everything. And yeah, this is just illustrative purposes. So let's talk about the other incident. Deleting production, fun Monday afternoon, things didn't quite work as they should. I was just playing around with the test cluster, but at some point I decided, well, it's late enough, let's start again with this tomorrow. Let's just delete this test system and bring it back tomorrow. The only problem was that I clicked on the delete button, of course, in the wrong environment. The wrong Google Cloud project. Takes you about 2 seconds after you press the final button to realize that this was wrong. Deleting a cluster in Google Cloud takes, depending on the cluster and what resources you're provisioning through the cluster and so on, takes some time, but let's say 20 minutes. Not the easiest 20 minutes. Yeah. At least we're not losing data, because the data lives in Redis and in Postgres, all that's outside the cluster. So none of the data is going to disappear, it's just all the applications that are going to disappear. And of course the CEO of Norrøna was in a presentation and it stopped working. These 20 minutes were actually the worst part, waiting for production to disappear so that we can actually start bringing it back, because again the assumption is there's only one cluster, so the Terraform code couldn't deal with the fact that there is a now deleting cluster still in existence. The next problem is that some of the objects within the cluster were also provisioned via Terraform. Really not a good idea. That took us a bit more time. Then finally we brought everything back, and I mean this had never been tested, yeah, because the cluster had been going for 5 years, upgrading all the time. That was all going fine. So the first time we brought it back, but everything looked good except the ingresses didn't want to come back. Some log messages that looked like this is the wrong path, but of course we misunderstood what was causing what. This cost us 1.5 hours to figure out why the ingresses weren't coming back. But after all, after 3 hours, we were back. So not the longest outage, but unfortunate. And the website, it's still on-prem, so that the actual website was working, people could still order things. So what did we learn this time? Well, the one thing is that naming is extremely important. Don't call your cluster cluster. Yeah? Call it production cluster or something. Because, I mean, even if you copy-paste the word cluster into that field, if you're copy-pasting production, the chances that you notice that you should not really be deleting production are a bit higher. No? Another thing we learned is that it's good to assume there's more than one cluster. We are now in a state where we can have multiple clusters in parallel. We can actually load balance between them. All that's now set up. We can bring up one cluster, switch over to the other cluster, and then tear down the first one, all this without anyone noticing from the outside. So if this were to happen now, we could already start bringing up the second cluster while the first one is still deleting. Probably not be done by the time the first one disappears, but I mean, we've done this switch a few times, so we know this is not going to take 3 hours. At least in this case, for the end users, there was limited degraded services. The Terraform restore all that worked, so all the hard work that gone into writing all this code, all the GitOps code also for Argo, all of this was working. The only problem were these Kubernetes resources in Argo CD. So we no longer do this. The actual installation of things into the cluster, there's one GitHub action that you have to run to create Argo, but then Argo takes care of everything else, and there's no more relation between Terraform and the cluster internals. We also went through a few more exercises on planning, okay, what if we'd actually deleted the database server? What if Redis had disappeared? How long does it take to restore Redis from the database? We're also working on the Google's Privileged Access Manager to make this, to add another step that you have to first click on, yes, I want to have the right to delete clusters in production today. Just as an added step of, yeah, I really want to do the scary things today. And these incident communications channels, there were some improvements done to this as well, because as I said, this happened late on a Monday. Everyone was already at dinner who needed to be notified, except for the CEO who was giving the presentation and me who was sitting at the desk trying to figure this out, and there was a gap in between. The final thing is that we're looking at the website should really be high available after we're done with this migration. So this is something we're looking forward to or looking into now. The final story is, because it's 2024, obviously you have to talk about artificial intelligence these days. And Norrøna is trying to use it for, as I mentioned, recommender API. One is the part where you want to tell customers, well, you're looking at this kind of jacket, maybe this kind of pants will go nicely with that. The other thing they're doing is analyzing customer feedback to find out if there's things that everyone's complaining about the same thing about these pants because the same seam is always ripping, maybe we need to fix that as an input for the support team, but also for the idea of having summaries on the website. Now, there's always some challenges with artificial intelligence, and in this particular case, I'm not sure how well this is legible, but this is the Norrøna Lyngen jacket, and Gemini thought this was the Bergen's helium hybrid jacket. As far as we can tell, that exact product name doesn't even exist, but it's still interesting that the competitor was showing up here. So there's ways to improve on this. They had a few back and forths also with Google. There's a method named grounding where you tell the LLM explicitly that there's no Bergens here. This is all Norrøna. But there's also the lesson that not all data can be used for all purposes, and you have to make sure that you have the actual or the right data for the right question. Finally, what's next? Where are we going from here? There's a few more things in the pipeline. Obviously, the website should move to the cloud so that the last services there can also be turned off and that we get rid of all the VPNs in between and sort of things that I wasn't talking about. Removing the other remaining on-prem infrastructure as well. There's a few more services that need to be re-implemented, but that's already been worked on. And finally, the data platform I mentioned with Looker, BigQuery, this is something that's still being worked on. Yeah, and with that, thank you very much.
Hello. Yeah. Thank you very much, Carsten. Any questions? No one interested in asking about Norrøna infrastructure? Okay. Thank you again. Give him a good applause. We'll use the 5 minutes we have extra to schedule the next talk, but it's going to be starting at once. So we'll just connect up here.